called special right triangles. So still kind of the Pythagorean theorem deal, but now they're called special right triangles because of this. You ready? So there's two different special right triangles. The first one we're going to look at today looks like this. It is a right triangle, but it's special because both of the angles that are not 90 degrees are 45. This is called a 45, 45, 90 right triangle, and it's a special right triangle. Today, you can solve for a missing length. It's supposed to be a 5. You can solve for x and y if you only have one length. So in Pythagorean theorem, you need two lengths to solve for the third one. With a special right triangle, you only need one length to solve for the other two. You should not be using Pythagorean theorem today. All right? One of these should be fairly obvious. You see what kind of triangle that is? Like specifically, how would you classify that triangle? Acute, obtuse, right, equilateral, scalene, isosceles. This is an isosceles triangle because it has two base angles that are the same. So every isosceles triangle has two equal angles and two equal sides. So if this side length is 5, how big is that length? X. 5. That will always happen every time, all the time with a 45, 45, 90 right triangle. And then we can do Pythagorean theorem now to solve for the other side, or you'll learn today that y is just equal to 5 square root of 2. That's the rule, right? They have this proportional side lengths, which is 1 to the square root of 2. So we'll explore this one for a little bit. And you notice it says every isosceles right triangle is a 45, 45, 90 right triangle. So pick a number for x. Besides 5. We just did that one. 7. So if x is 7, that means this side's 7, this side's 7, and this side is 7 square root of 2. Hooray! Because it goes x, x, x square root of 2. I don't know how much better that can be. It goes number, number, number with the square root of 2. And it is a right triangle. You want to see it? You want to make sure it works? Let me load my calculator. So if we checked 7 squared plus 7 squared, it should equal 7 square root of 2 squared. Pythagorean theorem should work if it is a right triangle. I can start some steps here. 49 plus 49 equals, I'll do that in my calculator. What's 49 plus 49? 98. So we're hoping that 7 square root of 2 squared equals 98. Let's check it. Add a calculator, and we're going to check parentheses 7 square root of 2. Close your parentheses, squared. Hey, 98. It does work. So it is a right triangle. So today I'm just going to give you guys a number and ask you to figure out the other two missing numbers. So it says to solve for the hypotenuse, you multiply a leg times the square root of 2. So what is this number 9 right here? A leg or a hypotenuse? A hypotenuse. Should be. This is a leg. So to solve for y equals the leg times the square root of 2. Or y equals 9 times the square root of 2. So we have to figure out what is 9 times the square root of 2. It's almost so easy it's tricky. 9 times the square root of 2 is 9 square root of 2. So what about x? How big is x? It's the same thing as the other leg, 9. So 2 things you have to remember. Jock, Naili, Jock, outside. So something you really need to remember, to go from the leg to the hypotenuse, you multiply by the square root of 2. How do you think you'll go from the hypotenuse to the leg? How do you think you go from the hypotenuse to the leg? If you go from the leg to the hypotenuse, you multiply. How do you go backwards? Divide. So 2 different things we're going to be doing today. Either multiply by the square root of 2 or divide by the square root of 2. So here we go. We have a hypotenuse. I need to use that hypotenuse and find the leg. And it says the leg is equal to the hypotenuse divided by the square root of 2. And you guys can see how nasty this might be. So what is the length of the leg? Or what is the length of the hypotenuse? 10. That is mathematically inappropriate. You can never have a radical as the denominator. Doesn't work. So how do you get rid, this is the hardest part of this whole concept. How do you get rid of the radical as the denominator? Or what is 10 divided by the square root of 2? This is the easy one. So ask questions now before we get to the hard one. So to get rid of the radical, you have to multiply it by 1. In the form, the square root of 2 over the square root of 2. So this will work. This will always happen the same way. If you just remember the steps, nothing will really ever change. 10 times the square root of 2, multiplying across the fraction. 10 times the square root of 2. 10 square root of 2. You need to be confident in doing that. And then the square root of 2 times the square root of 2 is always 2. That's like saying the square root of 2 times the square root of 2 is 2 times 2 under the radical is 4. What is the square root of 4? 2. You don't have to do that step every time. Just remember, the square root of 2 times the square root of 2 is 2. It's like saying 1.41 times 1.41 equals 2. And it is true. Now, one more step we have to clean up. What is 10 divided by 2? 5. So our answer is 5 square roots of 2. So S is equal to 5 square root of 2. Now, if this leg is 5 square roots of 2, how long is the other leg? The exact same thing. Okay, so a couple of things you guys should hopefully start to pick up on. If the hypotenuse is a whole number, the leg will have a radical. If the leg is a whole number, the hypotenuse will have a radical. It's one or the other. If you want to verify that your answer is correct, is 5 square roots of 2 times the square root of 2, that's going from the leg to the hypotenuse this way, is that 10? Well, 5 times 1 is 5. 2 times 2 is 4. What is the square root of 4? 2 times 5 is? 2. It works. There's a lot of mental shortcuts you can take here. That is the entirety of the concept I'm trying to teach you. Leg times the square root of 2 equals the hypotenuse. Hypotenuse divided by the square root of 2 equals the leg. You're going one or the other. So a lot of people have a hard time keeping that straight. Okay? And I think this is the easiest way to make sense. How do you go from something that's large to something that's smaller? Multiply to make it bigger or divide to make it smaller? You divide. So to go from here to here, you divide by the square root of 2. Because you're making it smaller. If you go from something that's small to big, you're going to multiply to make it bigger. So if I want to figure out how long the leg is, I need to divide by the square root of 2. I need to figure out 24 divided by the square root of 2. The exact same process we did last time. How do you get rid of the radical in the denominator? Multiply it by 1 in that nasty form. The square root of 2 over the square root of 2. That's multiplying it by 1. Okay? So if you remember the steps, 24 times the square root of 2 is 24 square roots of 2. You just kind of smash the two numbers together. The square root of 2 times the square root of 2 is 2. Okay, the last step, divide the whole numbers. What is 24 divided by 2? 12. Who hates this? This is not like fun math, is it? Is there any shortcuts that I can teach you? Yes. Are you ready? Notice what we started with. We started with a 24, right? And I told you earlier, if the hypotenuse is a whole number, the leg should have a radical. Anybody check what is 12 times 2? Huh. You know the radical has to be the square root of 2. Well, what's the other number on the outside that makes 24? Okay, we can go back a slide and check. What is the hypotenuse here? What is 5 times 2? Hey guys, I'm all about shortcuts. If the hypotenuse is a whole number, the leg should be something times the square root of 2, and those two numbers should multiply to make 10. It's a great shortcut. A great one. This is the hardest case when the hypotenuse is a whole number. Can you take a guess at what the leg might equal? We know that there has to be a radical over here somewhere. And what number times 2 equals 16? 8. Let's just double check it to make sure. If I want to go from here to here, from the hypotenuse to the leg, you have to divide by the square root of 2. So let me attempt to do that. 16 divided by the square root of 2. Step 1, multiply by 1. 16 times the square root of 2 is 16 square roots of 2. The square root of 2 times the square root of 2 is 2. 16 divided by 2 is 8. Oh, I just did all those steps in my mind. All about shortcuts, guys. They're supposed to be shortcuts for a reason. Uh-oh. Guess what? There's a whole number on the leg now. What should you expect to see on the radical? What should you expect to see on the hypotenuse? You should expect to see a radical over here somewhere. So if I'm going from a small length to a large length, how do I make something bigger? I need to multiply by the square root of 2. So now I need to do 7 times the square root of 2. What is 7 times the square root of 2? Don't know. It is just 7 square root of 2. Remember yesterday we said we had like 7 square root of nothing times nothing square root of 2. 7 times nothing is 7. Nothing times 2 is 2. So in this instance, when the leg is a whole number, you just slap the radical on it, make it the hypotenuse. Those are the only 2 instances we're talking about. All right? I'm going to save this for the next day. Now let's go here real quick. I'm going to speed forward. Oh no. Alright, here's everything you need to know right here. Hey, these are all 45, 45, 90 right triangles. So put this somewhere in your notes. Draw 4 45, 45, 90 right triangles. You ready? So there's only 4 ways this math will ever happen. Okay? If you have a whole number here, or if you have a whole number here. 2 whole numbers. Cool? Or not cool? You got it? So, if this is a 5, how do I get here? Multiply by the square root of 2. So what is 5 times the square root of 2? Okay. Now, if you have a whole number on the hypotenuse, what was the trick I told you to get back to the leg? You should expect to see the square root of 2 right there. Well, what number times the square, what number times 2 equals 10? So this is the one that works here. So going this way, we're dividing by the square root of 2. It's a crazy trick, and it will always work. Now, here's the other case. What if I have a radical here? How do I get back this way? What do I do over here? Divide by the square root of 2. So I need to evaluate what is 10 square roots of 2 divided by the square root of 2. Here's what happens. You ready? What do you get? 10. That's easy. That's not bad. Okay, and the last one, the ickiest one, is if you have a radical on the leg. How do you get here? Okay, I'll use some context clues here. If 5 square root of 2 times the square root of 2 equals 10, what do you think 7 square root of 2 times the square root of 2 is? What's 7 times 2? and that will always work. Those are all 4 cases that you'll see. You can always double check in your calculator to make sure it's true. Guys, this is part 1. Part 2 is the 30, 60, 90 right triangle. And we're going to push everything back a day. We'll look at 30, 60, 90 right triangles tomorrow. So save those notes. You have like 10 questions on your desk that you could try to see if you kind of get what's going on. Tomorrow we'll tackle 30, 60, 90 right triangles. All right, this is on the YouTube in case you need it.